we need to see whether this function f of x is sine of absolute value of x minus absolute value of x plus 2 times x minus 5 into cos of absolute value of x is differentiable or not, and if it is not differentiable, where all it is not differentiable, right? So firstly, cos of absolute value of x is always cos x, because cos plus x minus x, it doesn't matter. So this is actually 2 times x minus pi times cos x, right? Now this is actually a very smooth function, right? Because the absolute value of x we have removed. This actually cos x into some kind of x multiple, right? This is always smooth, right? Like for example, x cos x, or 10x cos x, or x cos x plus 10, whatever. Right, this kind of a smooth function, so we are not much worried about this. This is anyway differentiable. Right, now we are worried about only this part. Right, if all the functions are individually differentiable, then sum is obviously differentiable, right? So d by dx of, we all know u1 plus u2 plus u3 is equal to d by dx of u1 du1 by dx plus du2 by dx, whatever, like this. Right. If the functions are individually differentiable, obviously the sum is also differentiable. So now we have to check about this two. The sine of absolute value of x minus absolute value of x. Okay. So when x is greater than 0, this becomes sine x minus x. And when x is less than 0, this becomes minus sine x plus x. Right. Sine of minus x is less than 0, absolute value of x is minus x. And minus of minus x is plus x, right? We have these two functions, and we don't even need to do a lot of things here, because we also know when x is very small, x is close to 0, then sin x is also close to x, right? We know this, we have done this multiple times, right? So what does that mean? This value, when x is close to 0, whether right side or left side, this value is actually close to 0, x minus x equal to 0, or minus x plus x equal to 0, this value is actually close to 0. The graph actually is kind of flat at 0. Afterwards it changes. Okay, but at 0 it is kind of flat. So we can directly say that this one, whether x is positive or negative, when x is close to 0, this is kind of equal to 0. So it is differentiable. But nevertheless, if we want to show it formally also, okay, we have sin x minus x and minus sin x plus x. And to say this function is differentiable, what does that mean? The slope from the right hand side and left hand side should be same. What is our slope? Limit h tends to 0, f of x naught plus h minus f of x naught by h. What is this one? What is, we know the differentiation formula, right? This is x naught, and this is x naught plus h, x naught and x naught plus h. And obviously, this point is f of x naught plus h, and this point is f of x naught. So basically, y2 minus y1 by x2 minus x1 is x naught plus h minus x naught, which is h. Now, when these 2 points are very close, this becomes a tangent. Otherwise, it's a secant. Right? Basically, y2 minus y1 by x2 minus x1, when and x1 and x2 are pretty close. That is the definition of derivative or slope of tangent. Right? Now, when h tends to, when this limit exists, what does that mean? When h tends to 0 plus, h tends to 0 plus, and h tends to 0 minus, we should get the same result. Right? When h tends to 0 plus, okay, f of x naught plus h, x naught is 0, right? That is nothing but f of h minus f of 0 by h. We have to calculate this limit. What is f of h? This is sin h minus h minus f of 0, which is sin 0 minus 0, which is nothing, which is this only, right? By h, right? Limit h tends to 0 plus. Now we know this is nothing but sin h by h minus h by h, which is equal to 1. We know this limit tends to 1, so 1 minus 1 is actually equal to 0. So when we approach h, when we approach x from the right hand side or 0 from the right hand side, we already we know this limit, right? Sin h by h, when theta tends to 0, it is equal to 1. So the slope is equal to 0. Now when we approach h from 0 minus, what is that? Again, limit h tends to 0 minus, 0 minus. What is f of h? F of h is minus sin h plus h, right? Minus f of 0. F of 0 is again minus 0 plus 0, which is 0 by h, right? This is again nothing but minus of sin h by h plus h by h, which is equal to 1. This time it has become minus 1 plus 1, which is again 0. So the slope is actually 0 from both the sides, right? So this part is continuous. In earlier also we have proven this. The sign of absolute value of x minus absolute value of x is actually continuous. So this one is anyway continuous. So this function is actually always continuous. It is sum of continuous functions only. This one is continuous, this one is continuous, and sorry, differentiable also, not just continuous. This one is differentiable, this one is differentiable. This basically this is smooth at x equal to 0, right? Because slopes are coming same on both sides. So it is the correct answer is the k set is a real set of where the function is not differentiable. There is no such set, right? It's an empty set, right? At all places this function is differentiable, right? Guys, hope you like this. Thank you.